Hi students, welcome to Brilliant Qatar. Here we are discussing 100 MCQ from the chapter Chemical Kinetics, one of the physical chemistry chapter. As you know, they won't ask you very too long questions in this MCQ part. A simple question within seconds we can able to find it, especially it's an MCQ. But when you go for the descriptive type of question, yes, there will be a lot of calculation part will be there. So through the 100 MCQ, let us revise the entire chapter once again. Hope you all are ready. Let us start. Question number 1. The rate of a reaction increases 16 times. This is the 2024 board question. Okay, 2024 board question. A simple question. Rate of a reaction increases 16 times when the concentration of the reactant increases 4 times. So they didn't given any reaction here. So let me take a general reaction. Rate is equal to, let me write the rate law first. Rate is equal to K into the concentration of the reactant raised to X. We don't know what is the reactant and all. They're not given the reaction. So the rate of the reaction increases 16 times. Rate of the reaction increase 16 times, right? If it want to increase 16 times, what they did, concentration of the reactant increases 4 times. So that concentration of the reactant become 4R raised to X, right? Concentration of the reactant, they increased 4 times. Ready? Then what is the order of the reaction? You know what is order? It is the sum of the power. So what is the order of this reaction? If you want to get 16 times, what should be the order here? The X should be what? 2, right? Then only 4 square, we will get 16. The rate will be increased to 16 times. So what will be the answer? Option B, 2 is the order. So it is a second order reaction. So overall the rate of the reaction increases 16 times by increasing the concentration of reactant 4 times. So 4 square, then only you will get what? 16, right? Question number 2. The term minus dx by dt in a rate equation refers to what? Minus dx divided by dt, we will express the instantaneous rate like this one. Minus sign, what it indicate? Minus we are using for reactant and plus we are using for what? Product, because that minus showing that reactants are consuming in the reaction, plus indicate that products are forming in the reaction. So minus dx by dt indicate that option, let's go with option which one? B, the decrease in concentration of reactant with respect to what? Time. So decrease in concentration expressed by minus, increase in concentration of product expressed by plus sign. That you know. Question number 3, that is, for a reaction P plus Q gives 2R plus S, the incorrect statement is, what is that? Incorrect statement is, let's see all of you. Rate of disappearance of P. What is the rate of disappearance? We can write minus dP divided by dt equal to rate of appearance of S. Yes, S is also only 1 mole, right? So minus ds divided by what? dt. Correct. Rate of disappearance of P is equal to rate of appearance of S. Correct. Rate of disappearance of Q. What is in terms of Q? Minus dQ divided by dt equal to 2 into rate of appearance of R. What is in terms of rate of appearance of R? We know the coefficient. The coefficient, we will write it as the reciprocal, right? And dr divided by dt. Is it double? No, half of. Rate of disappearance of Q is half of rate of disappearance of which one? R, not double. So that is a wrong statement. Let's go with option which one? B is the correct answer. Ready all of you? Ready? Next question. In a reaction, they given a reaction 2x gives y. The concentration of X decreases from 0.5 to 0.3 in 10 minutes. So rate of X, right? Yeah. So can you say how you can write in terms of X? The rate is minus 1 by 2. Always the coefficient we have to take it as a reciprocal. Minus 1 by 2 into dx divided by dt, or change in concentration of X divided by change in time. So minus 1 by 2 into, what is delta X mean? Delta X mean X2 minus X1. Or R2 minus R1. That means final concentration minus initial. What is delta T? T2 minus T1. Change in time. So So that is equal to minus 1 by 2 into, what is the final concentration? Final is 0.38. So 0.38 minus, what is initial concentration? 0.5 divided by, within 10 minutes that over. So that is the final time. 10 minutes is the final time. Initial time is what? 0. We are starting 0. So what is that simplification? Minus 1 by 2 into minus 0.18 divided by, that's divided by 10, right? Sorry, 1, 2, right? 1, 2. So it's equal to 0.12 is there and divided by 20. But there is something we have to be take care here. Here I hope you can able to see that it is mentioned the rate of reaction is in molar per second. Molar per second. See, the time is given in minute. The unit and all, be very careful. The time is given in minute, but they were asking in second. So we need to convert the minute into second, right? So what you have to do that, divided, right? This divided by 10, that 10 is the minute. In order to convert into second, we have to multiply by 60. So it will be minus minus get positive. So that will be 0.12 divided by 1200, right? All right, so that will be, I'm taking the 0 into the numerator, so it will be 0.12 divided by 12 into 10 square. So that is 0.12 into 10 raised to minus 2 divided by 12. So 0.12, how we can write it as all of you? 12, right? So we can take it as 12 divided by 12 into 10 raised to minus 4. That's equal to 1 into 10 raised to minus 4. Where is that? Option A. So very careful about the unit, okay? Reaction is very simple. Rate is calculated by what? They given in terms of x. So minus 1 by 2 into dx divided by dt or delta x by delta t. That everything is okay. But time, it is given in minute, but the unit is in second. So don't forget to convert. Question number 5 for you, dear. Instantaneous rate of a chemical reaction. What is the difference between instantaneous rate and average rate? Instantaneous rate is calculated at a particular instant, but average rate is calculated between two time interval. So the rate of reaction in the beginning, no. Rate of reaction at the end, no. Rate of reaction at a given instant. So instantaneous rate is the rate which is calculated at a particular instant. Next one, a first order reaction has the rate constant. So rate constant K is given 1.5 into 10 raised to minus 3. Time taken for 5 grams. So time taken to convert 5 gram of the reactant to reduce to 3 gram. What is our equation for rate constant here? K is equal to 2.303 by T into log of initial concentration of reactant by final what is left. So here we need to calculate time, right? So let me just exchange with the time. Time equal to divided by K. So time equal to 2.303 by, what is the K value? 1.15 into 10 raised to minus 3 into log of, what is log? Initial and final. Initially is 5 gram, 5 by, finally what is left? 3 grams. So 5 by 3. What is log of 5 by 3? Dear, please remember the log values at least 1 to 10. Okay. Giving for you log 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Log 1 to log 10 value, please remember, it will be helpful for this chapter and the electrochemistry chapter. Log 1 is 0, log 10 is 1. So the remaining values are in between 0 and 1, right? Log 2 is 0.3. Exact value, you know, 0.3010. All right. This is 0.47 or 0.48. And this, please remember all. This is 0.6, 0.7, 0.77. How you memorize? 0.6, 0.7, 0.77. These three study as a set. This is 0.85, 0.9 and 0.95. All right. So what is log 5 here? 0.7 and log 3 is 0.47. So what is log 5 by 3? Log 5 by 3 is what? Log 5 minus log 3. That is 0.7 minus 0.47. All right, so we can able to simplify this one. So time here we need to calculate. You will get around 444 seconds. Please cross check. Okay, the calculation part you have to do it. You have to simplify it because that's the only way we have to make it what the calculation part faster. So time is to calculate. What is the equation? K is 2.303 divided by K into log R naught divided by R. Next question, for the reaction A plus 2B gives C, rate law is already given, right? Then the order of the reaction. What do you mean by order of the reaction? It is the sum of the powers of the concentration terms in the rate law. What is the power here? 1. Here power is 2. 2 plus 1 is equal to, it's a third order reaction. So what is order? Order is the sum of powers of the concentration terms in the rate law. Next one, order of a reaction is decided by, how we can calculate order? Order is given by the mechanism of the reaction. From the rate law you can find it, from the order you can find it, and you know it is an experimental quantity. So order of reaction is calculated by not temperature, mechanism. Yes, mechanism of the reaction as well as relative concentration of the reactant, right? Yes, it is an experimental quantity. Next one, a plot is shown below between concentration and time. Which of the given order is it? Is it a 0, second, first, or fractional? Very simple here. Please remember these two data very carefully, okay? This for zero order reaction, you may study. For zero order reaction, you may study one graph, one integrated equation, right? Integrated rate law equation you have studied. For zero order reaction, in between the derivation of the integrated equation, there is a equation comes R is equal to minus KT plus R naught. In between the derivation of zero order integrated equation, we will get an equation that R equal to minus KT plus R naught. It is in the format of a straight line what? Y equal to mx plus C. Alright. But for first order reaction, there is a small change, that is log R, ln R is equal to minus KT plus ln R naught. One log term comes, that's it, natural logarithm. This is also in the format of what? Y equal to what? Mx plus C. So dear, if R when plotted versus time, R plotted versus time, you understand it is zero order with a slope minus K. If ln R, if they use ln R versus time, if they use, there also slope is minus K. Remember, in both of the graphs, slope is same minus K. If log term is there, it is first order. Log term not there, it is zero order. Here you see all of you, log versus time. Log versus time means what? It is a first order graph. Careful, and slope is minus K. Next. A zero order reaction is one whose rate is independent of what? See, let me write the rate law for a zero order reaction. What is rate is equal to K into reactant. If it is a zero order, power should be zero, right? Yes or no? So what will be rate is equal to K? We'll get rate equal to K. So zero order reaction is one whose rate is independent of what? The concentration of the reactant, right? The concentration of the reactant. Zero order reaction in which the rate is independent of the initial concentration of reactant. Next, a catalyst increases the reaction rate by, what is the purpose of a catalyst here? Catalyst is a chemical substance which is reduce the activation energy and speed up the reaction. So it decrease the activation energy, right? It decrease the activation energy by which they speed up the reaction. Question number 12. A first order reaction takes 40 minutes. So time is given to you 40 minutes for 30% decomposition. Find its half-life. You know, half-life of first order reaction is 0.693 by K. So first we need to calculate K. Yes, K is equal to 2.303 by T into log of R naught divided by R. So is equal to 2.303 by time is 40 into log of what is initial concentration and final. 30% decomposition. So dear, initially you have 100, 30% decompose means what is left here? 70. Always numerator, if it is percentage, numerator 100, denominator what is left? Okay, 30% decomposition happen. So what is remaining? 70. What is log 10 by 7? Already with the values we discussed, right? Log 10 by 7 is what? Log 10 minus log 7. What is log 10? 1. What is log 7 value? Remember, log 7 value 0.8, right? 0.85 is there. 0.85. So you will get it here 0.15. That you can substitute here. You will get the value of K. That K value we have to substitute here. Then we will get the T half. Just to pause the video here and just to calculate and cross check the answer. You will get it around 77.7 minutes. It is already in minutes, so no need of any conversion. So if you want to calculate half-life, we need K. So K calculate first and substitute here. Next question. Which of the following influences the reaction rate performed in a reaction? See, what are the factors affecting rate, speed of a reaction? Temperature, yes, temperature when increases, speed of the reaction increases. Activation energy decreases, speed of the reaction increases. Catalyst if we use, that will reduce the activation energy and speed up the reaction. So all of the above, they are depend on rate of a reaction. For a second order reaction, what is the unit of rate constant? Dear, what is the general unit of rate constant? That is mole raised to 1 minus n, liter raised to n minus 1, second raised to minus 1. This is the order of which one is general order of rate constant. So second order means n is equal to 2. Where n is the order. So what is the value? Mole raised to 1 minus 2, liter raised to 2 minus 1, second raised to minus 1. That is mole raised to minus 1, liter raised to 1, second raised to minus 1. Is there any answer? Just check it all. Mole raised to minus 1, liter and second raised to minus 1. Mole raised to minus 1, liter, second raised to minus 1. So don't forget this order, okay? The unit of rate constant K is mole raised to 1 minus n, liter raised to n minus 1, second raised to minus 1, where n is the order of the reaction. Next one, the rate constant of a reaction is given. Rate constant K already given, all right? Find the order of the reaction. Simple, check the unit. From the unit, you will get it. Second inverse ln means what is that? It is first order because we have mole raised to 1 minus n, liter raised to n minus 1, second raised to minus 1. If n is 1, that means first order, 1 minus 1, 0. Mole raised to 0, 1. Liter raised to 0, 1. Only second inverse. So second inverse, if the unit of rate constant, no worries, it is first order. Next one, a reaction is given, takes place in 2 steps, all right. First step is slow step, second step is fast step. What is the information you are getting that slow and fast? Slow step is known as RDS, rate determining step. Rate of a reaction is given by not the fast step, it is given by the slow step. So this is the slow step we have. So no need to bother about the fast step. So slow step will give you the rate. So rate is equal to what? K into. Who is the reactant in slow step? NO2, right? NO2. The power, actually not in general information about this one. So coefficient we take it as the power. So R equal to K1 into NO2 square. So what is the point here? Slow step is the rate determining step. Ready? Next one. What is the rate law for acid hydrolysis? Do you remember this term, dear? Acid hydrolysis of an ester. Ester, right? Ester. Ester related reaction we studied. Ester hydrolysis, sucrose hydrolysis. These all follow what? Pseudo first order reaction. Pseudo first order reaction. So what is the rate law for acid hydrolysis of an ester such as? So the ester is given as CH3COOC2H5. This ester on hydrolysis, we know ester on hydrolysis, we will get carboxylic acid and alcohol. But here the point is, what is the rate depends on? Actually, rate depend on both of these. What is that? CH3, COO, C2H5 and H2O. So we may feel like it is second order or higher order like that, but actually it follow first order because H2O concentration we take it as what? 1. If H2O concentration is excess, if it is the water amount is excess, if the reactant is in excess in amount, its concentration we neglect, its concentration is 1. So H2O is in excess amount, so cut it. So rate depends only on whose concentration? The ester concentration. Therefore it follow first order kinetics. So reaction which appears to follow higher order, but actually it follow first order. What is that called? Pseudo first order reaction. So ester rate only depend on the ester concentration, that is what? K into CH3COO C2H5. Next one, what will be the fraction of molecules having energy equal to or greater than activation energy? You may study the Arrhenius equation, K is equal to A into E raised to minus EA by RT. You know what is this entire term represent? The exponential term E raised to minus EA by RT, the entire term represent fraction of molecule or amount of molecule having energy, kinetic energy equal or greater than activation energy. That is called E raised to minus EA by RT. So E raised to minus EA by RT is the definition of the statement. Righty? Next one. There is an ester, RCOOR means what? It's an ester. Ester on hydrolysis, you will get acid and alcohol. Just to be discussed now, it is an example for what? Pseudo first order reaction or pseudo unimolecular reaction. Which of the following statement about a catalyst is true? Okay, let us see catalyst. A catalyst accelerates the rate of reaction by bringing down the activation energy. Yes, catalyst is a chemical substance which reduces the activation energy and speed up the reaction. A catalyst does not participate in mechanism. Catalyst makes the reaction feasible. A catalyst makes equilibrium constant more favorable. No. Catalyst purpose is what? Reduce the activation energy and speed up the reaction. 21. For the reaction, they given the reaction N2 plus 3H2 gives to NH3. What is dNH3 by dt if it is like this? What is the value of minus C? See, so first our purpose is, they mention ammonia and hydrogen only, right? So ammonia and hydrogen, please take it out. Nitrogen we don't want. So can you say in terms of hydrogen, how we write the rate? Minus 1 by 3 dH2 divided by dt. Yes or no? Because the coefficient is 3 and so we have to take it as a reciprocal and it is a reactant, therefore minus sign. And how you write in terms of ammonia? Plus 1 by 2 into delta, the concentration of ammonia divided by dt. All right. And what value they given? This value, this dNH3 by dt, this value already given 2 into 10 raised to minus 4. So I can write minus 1 by 3 into dH2 divided by dt equal to 1 by 2 into 2 into 10 raised to minus 4. All right. So we can cut this one, right? 2 we can cut it. So what is the equation becomes? Minus 1 by 3 dH2 divided by dt equal to 1 into 10 raised to minus 4. Is it correct all? So question, what is the value of minus dH2 by dt? So minus dH2 by dt is equal to what? 3, we can put it there, 3 into 10 raised to minus 4, right? 3 into 10 raised to minus 4 mole liter inverse second inverse. Ready? Next one, for a chemical reaction A gives B, it is found that, okay, A gives B is given. So immediately write the rate law. How we write the rate law? Rate is equal to K into reactant A raised to X. We don't know what is the power. So it is found that rate of reaction doubled when the concentration of A increased 4 times. All right. Same one question we discussed. So if you want to double the rate, so K, what they did, when the concentration of A increased 4 times. 4 times they increased the concentration of A. They increase the concentration of A 4 times, therefore I put 4A. And by the if they increase the concentration 4 times, the rate is almost double. Correct. So the question, what is the order? If you want to get the overall what is the value of X is the question. If you want to get the value of X, check it here. When they increase the concentration of A 4 times, rate is doubled. So what should be the value of X? X should be what? 1 by 2. Right? 4 raised to 1 by 2 or square root of 4 is what? 2 times. Right? So it should be half. The order of the reaction should be half. Next one, the half-life of the first order reaction having rate constant. See, rate constant is given. What is the equation to calculate half-life? T half is equal to 0.693 by K, that is 1.7 into 10 raised to minus 5. So 0.693 by 1.7 into 10 raised to 5. So or you can take it 693 into 10 square divided by 1.7. So calculate all of you, you will get it. It is in second, right? It is in second, but answer is given in hour. So here the value which you are getting in second, how you convert into hour, that divided by 360. The value which you are getting here, okay, value which you are getting here, it is in second. If you want to convert into hour, what you have to do that? Divide by 60 into 60, that means 36, right? So the answer in hour, it will be converted to 11.3 hour will be the answer. So please take care about the unit. That is the main thing. So time here you are getting in second. So that second time you have to convert into which one? Hour. Ready? Next one. The role of a catalyst is to change what? Already we discussed. Is it Gibbs energy, enthalpy, activation energy? Which one, dear? The role of a catalyst is to change what? Activation energy of the reaction. Activation energy of a chemical reaction can be determined by. We studied there is an equation from Arrhenius theory, that is log K2 by K1 equal to EA by 2.303 R into 1 by T1 minus 1 by T2. This is the equation we are using to calculate the value of what? Activation energy. If they given to temperature, if they given to rate constant, we can calculate activation energy. So what is the answer here? Determining the rate constant. Option 2, determining the rate constant at 2 temperature. If they given 2 temperature and 2 rate constant, we can calculate the activation energy. Next one, for the reaction N2 plus 3H2, how are the rate of reaction expressed? dH2 by dt related to dNH3. Already we discussed that. Anyway, see, in terms of hydrogen, how we write? Minus 1 by 3 into dH2 divided by dt is equal to. In terms of ammonia, plus 1 by 2 into dNH3 divided by dt. All right. Okay. So which one, how is the rate expression is interrelated? Which is the correct one, dear? Check it all. Minus 1 by 3 dH2 by dt equal to minus 1 by 3 dH2 by dt equal to plus 1 by 2. Yes, option A, right? So for the reaction, how are the rate are related? Yes, it's correct, right? Minus 1 by 3 dH2 by dt equal to plus 1 by 2 dNH3 by dt. Cross check it, okay? Consider the reaction, okay, reaction given. If this value is given as K and this value as given as K dash, what is the relation? Simple. So firstly, let me write, how we write the rate of this one? Minus 1 by 2 into dN2O4 divided by dt is equal to plus 1 by 4 into dNO2 divided by dt. See, this value they given as K. So this is equal to what? K divided by 2 equal to, and this value they given as what? K dash. So it will be K dash divided by 4. All right. So cut it by 2. So 2 is left here. So K equal to what? K dash by 2. So K dash equal to what? 2K, right? 2K. K dash equal to 2K. So what is our answer? Option is B. Clear, dear? Question 28. A reaction in which reactants are converted to product P follow second order. So write the rate below. Rate equal to K into R raised to 2. Why it's 2? Because it is second order. If the concentration of R increased 4 times, if the concentration R increased 4 times, what happened? It become 4R square. What is 4 squared here? 16 times. So the rate increased by what? 16 times. What will be the increase in formation of P? That will be 16 time increases. Next, which of the following statement for order of a reaction is not correct? Order can be determined experimentally. Yes, order is an experimental quantity. Order of reaction is equal to the sum of the powers. Yes. Order cannot be fractional. Order can be fractional, 0, whole number, etc. So C is the not correct. Order cannot be fractional, wrong. Order can be fractional. But order is not affected by stoichiometric coefficient. Yes, it's an experimental quantity. What will be the rate equation for the reaction? This is the rate law. Rate equation is rate equal to K into, what is the reactant? X and Y, right? X and Y. The power we can't able to write. Yes, power we can't able to write. If the order of the reaction is 0, they already said it's a 0. 0 order means sum of the power should be 0. What is x raised to 0? 1. Y raised to 0? 1. So what is the rate is equal to? Only K, right? Rate is equal to just K. Next one. Rate constant of two reactions are given below. Yes, rate is given to you here. What is the order? From the unit we can able to say, see, this is second inverse. Second inverse is the order for which one? First order. First order. So second one is first order. Ready. What about the first one? See, what is our unit? Mole raised to 1 minus n, liter raised to n minus 1, second raised to minus 1. If you want to get mole raised to minus 1, what should be the order? It should be 2, right? Yes, then only it will be mole raised to minus 1. So first reaction is second order, second one is first order. So second order and first order is the answer. So from the unit we can able to identify the order of the reaction. 32, unit of rate constant for the reaction. Unit of the rate constant. All right. What is the general unit of rate constant? Mole raised to 1 minus n, liter raised to n minus 1, second raised to minus 1. Here what is n? N is the order. What is the order of the reaction? Rate law given. So 1 plus 2, 3 is the order here. So n is equal to 3. Substitute. So mole raised to 1 minus 3, liter raised to 3 minus 1, second right. So it will be mole raised to minus 2, liter square, second raised to minus 1. What is the correct answer? Mole raised to minus 2, liter square, second raised to minus 1. Clear? Simple. 33. The number of molecules of the reactant taking part in a single step of the reaction is indicated by molecularity of the reaction. What do you mean by molecularity? It is the number of reactant species which undergo simultaneous collision leads to the formation of product. Simply we can say it is the number of reactants, right? So number of reactants which undergo collision, that's called what? Molecularity of a reaction. For a reaction x plus y gives z, rate is directly proportional to x. All right. So rate is what? Directly proportional to what? X. All right. That means equal to what we can write? Rate equal to k into x. All right. What is the molecularity? Dear, molecularity from where you get? Molecularity we will get from the balanced equation. This is our balanced equation. One x is there, one y is there. So total 2 reactant is there. So 2 is the molecularity. Okay, 2 is the molecularity. And what is the order? Order is the sum of the power, right? It is what? First order reaction. So 2 is the molecularity. For 1 is the order of the reaction. Clear, everyone? All right. So molecularity is the number of reactant, and order if you want to take the sum of the power. Next one, observe the given graph carefully. Which of the given order are shown by the graph? Already we discussed ln r versus time is what? First order. Already we discussed that. This is first order. And what about this graph? Dear all, it is also first order. They are making confusion. Okay. This both are first order, option C. How this graph first order? What is the equation for rate constant here? K is equal to 2.303 by T into log of R naught divided by R. That is the equation for rate constant. Yes or no? So from this one, they plotted with time, right? Time versus this log R naught by R. So let y-axis, what you have? This term. So let me bring into the y-axis. So log R naught divided by R is equal to, what you can take it, it will be 2.303 divided by what? KT. So if you plot 2.303, okay, KT divided by, right? Yeah, it will be KT divided by 2.303, right? So if you keep it log R naught by R here, so KT divided by 2.3. So it is in the format of a straight line, y equal to what? mx plus c. What is c mean? Y intercept. It is 0. That you leave it. Therefore, it's starting from the origin. And y-axis, what you have? Log R naught by R. What is x-axis? They are taking time. And what is the slope? K divided by 2.303. See, this is the same graph for which one? First law of this order. Okay, first order reaction. Next, 36. Radioactive disintegration. Radioactive decay follow first order kinetics. Okay. Radioactive reaction follow first order kinetics. General fact. What will be the half-life of the first order reaction for which the value of rate constant? Again, rate constant is given 200 second inverse. Calculate half-life. What is the equation to calculate half-life, dear? 0.693 divided by K, that is equal to 200. So let me take it as we can write 693 into 10 raised to minus 3 divided by 2 into 10 square. When you take into this one, it will be 10 raised to minus 2. So it will be 693. All right, that's enough. 6.93 is enough, right? 6.93 by 2, 6 by 2, 3 something. So 3 something will be the value, and what should be the power? Power we have to just cross check it. Okay, 6.93. Okay, so we can take it as 6. Now it is what? 693 into 10 raised to minus 3 divided by 2 into 10 square. So 693 into 10 raised to minus 3 divided by 2 into this 10 raised to minus 2 will comes. So 693 divided by 2 into 10 raised to minus 5. So if you take it 6 point, because 3 point means 6 point is enough, right? So I can write 6.93 divided by 2 into 10 raised to minus 3. So 6.93 is 3.4 something. Yes, into 10 raised to minus 3. Answer is which one? Option A. Next one, in pseudo unimolecular reaction. In pseudo first order reaction, what is the factor? One of the reactant is present in excess. Do you remember in ester hydrolysis and sucrose hydrolysis, where water part, why we are cutting? Because it is in excess in amount. The substance which is reactant, if it is in excess in amount, its concentration we can neglect it. Therefore, it comes to higher order to first order. The temperature dependence of the rate of a chemical reaction can be explained by Arrhenius equation. What is Arrhenius equation? K is equal to A into E raised to minus EA by RT. Where is that? K is equal to A into E raised to minus EA by RT. Next one, the energy diagram for a reaction P plus Q gives R plus S is given. What is A and B? What is A? A is this one. Dear all, this is reactant, this is product. What is this stage is called? This is the intermediate. This is the intermediate or the transition state. The energy difference between reactant and the intermediate stage, that is given as A, that is our activation energy. What is activation energy? The energy difference between reactant and the activation state or intermediate. So A is activation energy, B is what? The enthalpy, that means the heat of the reaction. Alright, so A is the activation energy, B is the heat of reaction. Careful about the graph and all given in textbook. 41, the temperature dependence of the rate of a chemical reaction is given by Arrhenius. Yes. Which of the following graph will be a straight line here? What is the equation? The equation is K is equal to A into E raised to minus EA by RT. We studied an important graph here. Taking logarithm on both sides, it becomes ln K equal to ln A minus EA divided by RT. It is in the format of a straight line. Y is equal to mx plus c. If you plot the graph, what is on y-axis? ln K, right? Y-axis we have ln K. X-axis we are taking 1 by t. X-axis we are taking 1 by t. Then what is the slope? Minus EA by R. Minus slope will be, slope is equal to what? Minus EA by R. And what is C? C is the y-intercept. What do you mean by y-intercept all? This distance, that is equal to ln A. So if you want to get a straight line, you have to plot ln K versus what? 1 by t. ln K versus what? 1 by t. Next, the decomposition of a hydrocarbon follows the equation. K is equal to 4.5 into 10 raised to 11 into E raised to minus 28,000 divided by temperature. K is Kelvin, okay. what will be the value of activation energy? See, this equation is very close to our Arrhenius equation. What is Arrhenius? K is equal to A into E raised to minus EA by RT. So A is this one. We can match it. LHS is equal mean RHS we can equate. So these are equal. So I can equate this with this one. So I can write minus EA by RT equal to E raised to minus 28,000 divided by temperature. So exponential we can cut it, minus we can cut it. So what we can write? We can equate this with this one. So EA divided by RT is equal to 28,000 divided by T. So temperature cancel. So activation is equal to what? 28,000 into what is R? That is the universal gas constant, 8.314. It is in joule, right? Joule, Kelvin inverse, mole inverse. But answer is given in kilojoule. So you should multiply with the 10 raised to minus 3. Then only joule become kilojoule. Check it all of you. The value will be around 232.79 kilojoule per mole. 43. The increase in concentration of the reactant leads to change in what? If you increase the concentration of the reactant, there is more chance to what? More collision and leads to the formation of more product. So if you increase the concentration of the reactant, collision frequency, what do you mean by collision frequency? Z, we studied in collision theory. It is a number of collisions happen per unit time and unit volume. That is called collision frequency. So more reactant, if it come, more collision free chance is there. So collision frequency increases. Rate of a general reaction A plus B product can be expressed as follow. Okay, rate is given here. What is Z? Z is the collision frequency. A and B are the reactant. Which of the following statement is not correct for the above expression? Not correct. Z is collision frequency and is equal to the number of collision per second per unit volume of the reaction. Yes. E raised to minus EA by RT is the fraction of molecules having energy greater than or equal to which one? Or activation energy. EA is activation energy, correct. All the molecule which collide with one another makes effective. No. All the molecule which cannot make an effective collision. What is the condition for effective collision? We studied according to collision theory. The colliding molecule should be properly oriented and colliding molecule should have an energy equal or greater than which one? The threshold energy. So these two conditions, if it there, then only effective. All molecule cannot make effective collision. Next one, for the reaction H2 plus Br2 gives to HBr, rate is given to you. Which statement is true about this? They are asking about the order. Just to calculate the order. Here power is 1, here power is 1 by 2. What is 1 plus 1 by 2 is 3 by 2, right? Alright. The reaction is of second order. No, the molecularity of the reaction is 3 by 2. What is the molecularity? Molecularity means number of reactant. 1 plus 1, 2 is the order. Unit of K is second inverse. Second inverse is first order, right? No, it's 3 by 2. Molecularity of the reaction is 2. Yes. Molecularity is what? 1 plus 1, 2. And order is what? 3 by 2. Molecularity is the number of reactants, or it is 2. Which is true, right? Yeah. Next one. Consider the reaction, first order reaction. Yeah, it's a direct question for exam. We studied if all reactants and products are in gaseous state. We studied an expression for rate constant for first order, that is 2.303 divided by T into log of Pi divided by 2 Pi minus Pt. What is Pi? Initial pressure. Pt is the pressure at the time T. So what is the equation? K is equal to 2.303 by T into log Pi divided by 2 Pi minus Pt. Option B. When we can use this equation? When all the reactants and products are in gaseous state. Next one. According to Arrhenius equation. Let's just we discuss now the Arrhenius equation graph. Which of the following option represent the graph? Log K, ln K was 1 by T. Let's just we discussed that was the negative slope, right? Negative slope is which one? Option A. ln K was 1 by T when they plot. Where we discuss this? See all of you that equation where we discuss. See ln K was 1 by T. We got a negative slope with the minus EA by R is the slope and ln A is the y-intercept. Ready? So the answer is which one? The first one. Next one. Which of the following expression is correct for the rate of see the equations option wise you select. Okay, bromine is there in the option H plus is there in the option. So how we write in terms of bromine and H plus? Let's see. In terms of bromine, I can write minus 1 by 5 into bromine concentration divided by time equal to, in terms of this, how you can, that is also reactant, minus 1 by 6 into H plus concentration divided by time. So question is this one. Which one is correct? Okay, delta Br minus, okay, this all are delta Br. So I can write delta Br minus delta T is equal to what? 5 by 6, right? Minus minus we can cancel. 5 by 6 into delta H plus divided by delta T. So where is this? 5 by 6. Delta Br minus dt equal to 5 by 6 into delta H, right? Option C. Next one, a first order reaction is 50% completed. What do you mean by 50% completed? It's half-life. What do you mean by half-life, dear? It is a time taken for an object to reduce into half of the initial amount. 50% completed mean half-life is given 1.26 into 10 raised to 14 second. How much time will it take to 100%? Dear, no need of any calculation, directly write infinite. Why? 100% decomposition for an object is not defined one, it's an infinite. It may take infinite time. Okay. Next, for the elementary reaction, what do you mean by elementary? It happened in a single step. P gives Q. Okay, P gives Q is the reaction. The rate of disappearance of P increases by, what is the rate of, P is reactant, right? It will decrease. Rate of disappearance of P increases by a factor of 8 upon doubling the concentration of P. So can you tell me the rate law? First of all, rate equal to K into P raised to X. All right. What they're saying, rate of disappearance of P increases by 8 factor, by a factor of 8. Okay, 8 times it increased upon doubling the concentration of P. So it is doubled to P. Then what is the order? If you want to get 8 times the order, they increase the concentration P double. So 2P. So what should be the power? If you want to get 8, what should be the power of 2? What is 2? Can you say dear? What is that? 2 raised to 3, right? 2 raised to, what should be the power of this X? It should be what? 3. Then only 2 raised to 3, right? 2 raised to 3, right? 2 into 2. Yes, it will be 8 times. So what will be the order of the reaction? What will be the order of the reaction? It will be third order reaction. It will be third order reaction. So they like that. I think 3 questions we discussed the same type. So this is the same one question they asked in the 2024 board question. Next one, when a catalyst increases the rate of a chemical reaction, then the rate constant. When a catalyst increases the rate of a chemical reaction, rate constant. Dear all, rate constant. What is rate constant? K, right? Rate constant is a fixed one. It is not able to change by a catalyst. Rate constant only depend on temperature, remember. So rate constant do not remain constant if a catalyst, catalyst purpose is reduce activation energy and speed up. 52, rate constant in case of first order reaction is, what is the expression for rate constant for first order? Is equal to 0.693 divided by T half, related to half-life like this. Rate constant in case of first order reaction is inversely proportional to the concentration, independent of concentration. See, independent of concentration terms. See, in this expression of rate constant K, is there any concentration term? No. So for first order reaction is what? Independent of the concentration units. Next one, the rate of a gaseous reaction is given by, so rate is already given. Okay, so the given rate is what? K equal to A into, rate is given as, rate is equal to K into A into B square. All right. If the volume, very carefully read the question, my dear, very carefully. If the volume of the vessel is reduced to 1/2 of the initial volume, what happen if you reduce the volume? Concentration double. If you reduce the volume half, concentration in the system will be double. That is the main point, okay? If you reduce the volume half, concentration is doubling. So when the vessel volume they reduce to 1/2 of the initial volume, then what happened? The new rate is equal to, if they reduce the volume half, concentration of each reactant double. So A becomes 2A, B becomes 2B square. So 2 square is 4. 4 into this 2 is what? 8 times the rate of the reaction increases. One more question for you here. Rate of a gaseous reaction is given by, here also rate is given. Rate is equal to K into A square into B cube. All right. The volume of the reaction vessel is reduced to 1/2 of the initial volume. Okay, reduced to half mean what happened? The concentration become double. So K into 2A square and 2B cube. What is 2 cube? 8. 8 into 2, what? 8 into 2, 2 square, right? Sorry, 2 square. Here 2 cube is 8, 2 square is 4. 4 into 8 is what? 32 times. Okay, 32 times the rate of a reaction. What will be the rate of as compared to the original rate? A. So if the initial rate is A, now it is 32 times of A. Now unit of rate and rate constant are same for which one? Zero order. Dear all, for a zero order reaction, how we write the rate? Rate is equal to K into R raised to 0. Zero order mean power should be 0, right? So what is this equal to? Rate is equal to what? K. So for zero order reaction, unit of rate constant and rate, which one? Similar. Under what condition a bimolecular, okay. Under what condition a bimolecular reaction may be of first order? Already we discussed in pseudo first order reaction, ester hydrolysis, right? Ester is there, water is there. But you may feel like its power is 1 plus 1, 2 is the order. But water is excess in amount. So water part cut, so it's only unimolecular. So when a bimolecular become unimolecular, when one of the reactant is in excess in amount, when one of the reacting species is larger in excess in amount. Which of the following statement is not correct? Let's see which is not correct. For a zero order reaction, T half is proportional to initial. Yes, what is the expression for half-life of zero order? That is equal to R naught divided by 2K. Yes, it is directly. The relationship of variation of log K2 by K1 equal to A by 2.32 minus T1. Yes, it's correct. Unit of rate constant for a reaction is mole raised to 1 minus N liter raised. Yes, correct. Where N is the order. Molecularity can be 0. No. Molecularity 0 means there is no reactant. Reaction do not happen. Molecularity always what? Whole number. It's not possible. Fractional or 0. Next one. Rate constant is given by. Yes, this is our collision theory given an equation. Rate constant key. What is P all? Probability factor. P is what? Probability factor or steric factor. Z is the collision frequency, is the exponential. Which factor should register a decrease for the reaction to proceed more rapidly? Which factor? The rate constant is given by the equation. Which factor should register decrease for the reaction to proceed more rapidly? Which one? See, which factor should register in decrease in value? See, if the activation energy is lesser in amount, the exponential term will be less. So the rate will be what? The exponential term of minus, right? So EA, if it is lesser in value, this value will be what? Greater in amount, because it's negative term, right? So K will be more. Anyway, we know activation energy decreases mean what? The rate of the reaction increases, right? Next one is, all right, next one. For a reaction, certain reaction, large fraction of molecule has energy more than the threshold energy. Still, the rate of reaction is very slow. If there are more reactant, then also we can't able to say that more reaction can happen. So they are saying even there are more reactant, why reaction rate is speed is very less. The possible reason for this could be that the colliding molecule could be large in size. colliding molecule must not be properly oriented. Properly oriented. Rate of reaction could be independent. One of the reaction could be no. If the colliding molecules are properly oriented, then only the reaction speed will be greater. In a reaction, the threshold energy is equal to, what is the threshold energy? It is the sum of activation energy and normal energy of the reactant. Okay. Threshold energy, what actually we discussed threshold energy definition. It is a minimum amount of energy required for that reactant to make an effective coalition. So threshold energy is the sum of what? Activation energy and the normal energy of the reactant. Now, for a reaction A plus B, they given already the rate to law. What is the order of the reaction? What is order? Sum of the power. Half plus 2, right? What is half plus 2 is equal to 5 by 2. That's equal to 2.5. Now, for a first order reaction, that ln, okay. ln R versus time graph slope is, we discussed already in the beginning question. For a first order reaction, there is an equation log R is equal to minus KT plus log R naught. Alright. This is in the format of a straight line. Y is equal to mx plus c. So when you plot y-axis ln R, x-axis time, you will get a slope. You will get a positive slope, negative slope, because minus k is the slope. What is the slope? Minus k. Even for zero order and first order, that graph is, the slope is what? Minus k. Next, a compound A and B are reacted. This type of question, many times you may practice in classes. So the reaction is given as what, dear? A plus 2B gives 2C, right? So immediately write the rate to law. Rate to law is equal to what? K into A raised to X into B raised to Y. Because we can't able to predict the order, right? Order is the sum, practical. It's an experimental quantity. They're given some data. What all data are given here? All A concentration given, B concentration given, its rate is also given. They conducted how many experiments? 3 experiments. All the 3 values you make into the rate to law. This is the rate to law, right? What is the rate according to the first experiment? The rate is 0.005 equal to K into, at that time, what is A concentration? 0.01 raised to X, B concentration 0.01 raised to Y. All right, this is according to equation number 1. According to experiment number 2, what is the rate? 0.02 equal to K into, at the time concentration 0.02 raised to X into 0.01 raised to Y. And according to experiment number 3, what is the rate? 0.06 equal to K into 0.02 into 0.03 Y, and here it is X. Now simplification, very simple. They're all let me take the, okay, that's okay, right? All right, let me take 3 by 2. Okay, I'm going to do 3 by 2. What is 3? That is 0.06 divided by 0.02 equal to K into 0.02 raised to X into 0.03 raised to Y divided by K into 0.02 raised to X into 0.01 raised to Y. Okay, we can simplify that. What is this? 0.06 divided by 0.2, 6 by 2, right? 6 by 2 is equal to 3. K cut, this term cut. 3 by 1 is 3, so 3 raised to Y. What should be the value of Y to make it 3? It should be 1, right? 3 raised to 1 is 3, so Y is equal to 1. So with respect to B, the order is Y and it is equal to what? 1. Now, what is the value of X? If you want to calculate the value of X, which all values we have to take it all, let me do that. 2 divided by 1. Yes. 2 divided by 1. If you do 2 divided by 1, you will get 0.02 by 0.005 equal to K into 0.02 raised to 0.02 raised to X into 0.01 raised to Y by K into 0.01 raised to X into 0.01 raised to Y. Okay, we can simplify this 2 term cut, K cut. So that will be is equal to, what is this? This is 2 into 10 raised to minus 2 by 5 into 10 raised to minus 3, right? So what it will be? 2 into minus 3, when you take into the h1, it becomes 20. 20 by 5 is equal to what? 4. 4 is equal to, this is what? 2 raised to x. So what should be the value of x to make it 4? 2 square, right? 2 square is 4. Therefore, x is equal to what? 2. So with respect to x, the order is what? 2. So where is the answer here? Where is the answer? So the rate is equal to k into a raised to 2, b raised to 1. A raised to 2, a raised to 2, b raised to 1. Option D. Rate equal to k into a raised to, with respect to x, it is 2, and y with respect to 1. Correct all? Next. Chemical reaction which occurs slowly at room temperature. Which chemical reaction happens slowly at room temperature? Simple one. Rusting of iron, right? It takes more time. Question 65. Which of the following statement is correct? Which of the following statement is correct? 1. The rate of a reaction, which means speed of a reaction, decreases with the passage of time as the concentration of reactant decreases. Correct, right? During a reaction, what happens? Reactants are converted to product. When reactants are converted to product, as time goes, what happens? Reactant amount decreases. When reactant consume, what happens? Rate of the reaction slowly decreases. Whenever we starting a reaction, beginning the reaction will be more rapid because more reactants are there, more reaction can happen. As time goes, the reactants are consuming, so the rate of the reaction gradually decreases. That is the correct statement. Let's go to question number 66. The average rate and instantaneous. What is average rate? Which is calculated between two time interval, but instantaneous is calculated at a particular instant. When average rate and instantaneous rate of a reaction are equal, so that we can go with when two rates have a time interval equal to 0. When the two rates have a time interval 0, at that point only the average rate, instantaneous rate can be equal. Rate of a reaction can be defined as, what is the definition of a rate? Rate of decrease in concentration of any one of the reactant, rate of increase in concentration of any one of the product, rate of decrease in concentration of any one of the reactant, or the rate of increase in concentration of any one of the product, the sum of the rate of decrease in concentration of all the reactant, or the rate increase. No. So what we can go with here? See, rate of a reaction we can say either by the decrease in concentration of reactant or in increase in concentration of product. You can express in both the reactant and product. The rate of reaction between two specific time interval. Between two time interval, if you calculate the rate, then it is called what? Average rate. In the beginning, decrease in the concentration of reactant is, in the starting of a reaction, reactant will consume faster. Means the reactant concentration in the beginning, the decrease in concentration of reactant will be rapid. More reactant will consume. The rate law for a reaction A plus B given C plus D in the expression is K into A. So rate law is given as rate is equal to what? K into A is only given. The rate of reaction will be doubled on doubling the concentration of B. No, the rate expression already given A, right? So it not depend on B. Halved on reducing the concentration of A to half. So the rate of reaction will be halved on reducing the concentration of A half. If you reduce the concentration of half, what happened? Rate also reduced to half, right? Yes, let's go with option which one? B. What about 3? Decreased on increasing the concentration of the reaction unaffected by any change. No, if you halved on reducing the if A, because rate only depends on A. If A concentration reduced to half, rate also reduced to half. Halved on the, okay, next one is the rate constant of a reaction depends on rate constant K. K only depend on which one? Temperature, okay, temperature of the reaction. Rate law for the reaction is given, all right. The concentration of reactant B is double. Okay, so initial the rate is given as K into A into B. All right. Now they increase the concentration of reactant B double. So what B concentration becomes 2B, all right. Keeping the concentration of A constant as it is, all right. Then the value of rate of the reaction will be, there is no power, right? Only that doubled. So what will be? It will be 2 times, right? It will be almost double, correct or not? The concentration of reactant B double, so it's 2B, and keeping a concentration of A same, right? So it will be double. Next one, which of the following will leads to an increase in the rate of the reaction? Where there is an increase in speed, decrease the temperature. No, temperature should increase, then only rate increases. Decreasing the concentration of reactant. No, addition of catalyst, right? Catalyst, if you increase, added, what happened? It reduce the activation energy and speed up the reaction. Inhibitor means it will prevent the activity of the catalyst. Now, what happens to the value of Gibbs energy? Gibbs energy for a reaction when catalyst is added remain unchanged. Their catalyst function is only affecting activation energy, no other thermodynamic factors. If the surface area increase, if more surface area present, reaction rate increases. More surface area, more reaction rate. So surface area increase, the rate of the reaction increases. Statement 1. The molecularity of a reaction may be either whole number or fractional. No, molecularity is always what? Whole number. So assertion is, or the statement 1 is wrong. Molecularity is the number of molecule take part in a single step. Yes, it's correct. So statement 1 incorrect, statement 2 is correct. Next one. For a single step reaction, 2x plus 2y gives product. Molecularity is, what do you mean by molecularity? Sum of the reactant. What is 2 plus 2 is equal to 4. Statement 1. For complex reaction, complex means reaction happening multi-step. For a complex reaction, order of reaction is not influenced by the stoichiometric coefficient. For a complex reaction, order of the reaction is not influenced by the stoichiometric coefficient of the reactant. It can be determined only experimentally and is always a whole number. No, order can be 0, fractional, right? It's not whole number. Statement 2, order of a reaction is the sum of powers of the concentration terms of reactant in the rate law. Correct. So statement 1 incorrect, statement 2 is correct. The order of reaction can be integer, fractional, and 0. Order can be 0, fractional, whole numbers. If statement 1, if in a 0 order reaction, the concentration of the reactant is double, the half-life period is also double. See, in 0 order reaction, what is half-life? Is equal to R0 divided by 2K. Correct? So in 0 order reaction, the concentration of the reactant is double. If R0 is double, half-life is also double. Yes, they are directly proportional. Correct. For a 0 order reaction, the rate of reaction is independent of the initial concentration. Yes, for 0 order reaction, rate is equal to what? Just a K. It is independent of initial. So both the statement 1 and statement 2 are correct. Molecularity of the reaction molecularity should not be 0 or fractional, right? So molecularity should not be what? Fractional, 1.5. For the reaction R gives P, the concentration of reactant changes from 0.03 molar to 25 minutes. Calculate the average rate. Okay, R gives P, right? So instead of R, in terms of R, how we can write the rate? Rate is equal to minus dr divided by dt is equal to final concentration minus initial. What is final? 0.02, initial 0.03. What is the time? 25, initial time is 0. So it will be minus and minus get positive, 0.01 divided by 25. Yes, that's equal to what? It is given in minute, right? It is given in minute, but it's necessary to convert into what? Second. So after converting the minute into second, you can cross check it, all of you will get. Same one question we discussed, right? Same time. So initial and final concentration is given. It is in the numerator. Final time and initial time is given denominator, but time is given in this value. You will get in second. Minute, because time is we calculated in minute, but the answer is in second, so that into 60 you will get the answer. Next one, the conversion of molecule X to Y follows second order. Conversion X to Y follow second order. So what is the rate law? Rate equal to K into X raised to. See the second order means power should be 2. If the concentration of X increase to 3 times, so it will be what? K into 3x square. What is 3 square? So 9 times. So 3 times. How will they affect the rate? It will be 9 times increases. Rate of the chemical reaction doubled for the increase of 10 Kelvin in absolute temperature from 298. Calculate EA. We know they given the T1 and T2 here. Can you able to understand? See, rate of the reaction is double. So K1 and K2 also given. Take it initial rate constant K1 itself and the final concentration will be 2K1 because they double. They said rate of the reaction double. So final rate will be 2K1. If it is quadruple, they said 4K1. Triple means 3K1 like that. An increase of 10 Kelvin in absolute temperature from, so temperature T1 is given 298 Kelvin. Now 10 Kelvin they increase. So 298 plus 10 is equal to what? 308 Kelvin. And they're asking to calculate activation. If 2 temperature given, 2 rate constant given, we have an equation what? Log K2 by K1 equal to EA divided by 2.303 into R. What is R? 8.314. It is in joule, but answer is in kilojoule. So into 10 raised to minus 3 into 1 by, what is T1? 298 minus 1 by 308. Okay, it will take time. So just calculate everyone. So slowly calculate and practice it. So what will be log K2 by K1? K2 we written as 2K1, right? So we can write as 2K1 and K1 is K1 itself. K1 by K1 is what? Log 2, you know, 0.3. 0.3010, 0.3 is enough. Okay, so we will get around 52.8 kilojoule per mole. Cross check it all of you, the value. 85, half-life for radioactive decay carbon-14 is. So half-life is given 5730 year. An archaeological artifact containing wood had only 80%. They contain only 80%, which means finally only 80 is left. So what is the expression for question? Estimate the age of the sample. So time we need to calculate. If you want to calculate the time, the equation for first order 2.303 by K into log of what? R naught divided by R. Yes or no? So T half is given, mean calculate K. 0.693 divided by 5730 here. It's already in here, so no need to convert. So this is K value that you have to substitute here. So T equal to 2.303 divided by 0.693 by 5730 into log of, what is initial and final? 80% only remains, which means initially you have 100, 80%. What is remaining that should be in the denominator. All right. So what is log 10 by 8? Log 10 minus log 8. What is log 10? 1. Log 8, I think we discussed around 0.9, right? So it will be 0.1. Okay. So that way we can able to what? Calculate the time. So just to calculate the time all around 1845 years. For a reaction R gives P, half-life is observed to be independent of the initial concentration of reactant. What is the order? We discussed that half-life is 0.693 by K. For which order? First order reaction. For first order reaction, half-life is independent of R naught, initial concentration. So independent of the initial concentration, that is for first order. Those reaction which takes place in one step, what do you call? Elementary step, right? Elementary. The reaction which happen in single step is called elementary, which reaction happen in multi-step called what? Complex reaction. The number of collisions per second per unit volume of the reaction mixture is called what? Collision frequency Z, right? Z, collision frequency. Then according to collision theory, conditions to undergo effective collision, 2 conditions are there. The colliding molecule should be properly oriented and colliding molecule should have a minimum energy which is equal or greater than the activation energy. So what is that? A is there, B is there. Both A and B are the condition. ZAB is the reactant, okay. Z is what? Collision frequency. ZAB related to rate of the reaction. how it is. According to collision theory, rate is equal to P's probability factor into collision frequency into e raised to minus EA by RT. So how ZAB related to the rate of the reaction? Directly proportional. In the Haber process, you know what is Haber process? N2 plus 3H2 gives 2NH3 is called preparation of ammonia. Industrial preparation of ammonia is called Haber process. Question, what is the catalyst is used? Here all the catalyst is iron. Iron with a molybdenum as a promoter. Promoter means to increase the activity of the catalyst. So in Haber process is the preparation of ammonia. Please remember the catalyst is which one? Iron. For a zero order reaction, relation between T half and R naught. How? For zero order, the half-life is related to R naught here. That's equal to R naught divided by 2K. So T half is directly proportional to what? R naught. So T half is equal to R naught divided by 2K. Next, which of the following statement is true? Molecularity of a reaction can be zero or fractional. No, molecularity should not be zero or fractional. Molecularity has no meaning for complex reaction. Yes, molecularity is only for which one? Molecularity we can say only for elementary reaction, not for complex. Molecularity of a reaction is an experimental. No, it's a theoretical quantity. Reaction with the molecularity 3 are very rare but are fast. Yes. So molecularity has no meaning in complex. It's only applicable in elementary. 94. For a zero order reaction, A gives P. The rate equation. What is the expression for rate constant for zero order, my dear? Equation is what? R naught minus R divided by T, right? This is the integrated equation we derived. So K equal to R naught mean A naught. So K equal to A naught minus A divided by T. Option A is the answer. The expression they were asking, right? Next one. The slope in the plot of ln R versus time for a first order reaction is. Zero order we discuss, first order also ln R versus time if you plot, or this is for first order R versus time if you plot. In both, this is for zero order. This is first order, this is zero order. For both of them slope is what? Minus K, alright? Minus K. The y-intercept in the plot of ln K versus 1 by T is, hope you remember that equation. What is the equation? Arrhenius equation. K equal to A into E raised to minus EA by RT. Taking logarithm on both sides. Log K equal to log A minus EA by RT. When we plot a graph y equal to mx plus c. What is on y-axis, dear? ln K. Right? ln K on y-axis. What is on x-axis we are taking? 1 by T. And what is the slope? A slope is m, that is negative slope minus EA by R. What is the y-intercept? Y-intercept is C, that is what? ln A, right? ln A is the y-intercept. Time required for 99.9% completion of a first order reaction is dash time, the time required for 90%. Our equation is what? K equal to 2.303 or time. Time equal to what? 2.303 by K into log of what? R naught divided by R. This is the expression for time for first order, right? So let me write for 99.9% completed mean. What is expression for time for 99.9%? That is equal to 2.303 by K into log of. What is initially we have 100. 99.9% completed mean what is left? Only 0.1% is left. Yes or no? So what it will be? This is 10 raised to 0.1. I can write it as what? 10 raised to minus 1. When it is taken to that, it will be log 1000, right? It will be log 100 into 10. It will be log 1000. What is log 1000 is? Log 1000 I can write it as log 10 cube. What is log 10 cube? 3. 3 into log 10, 3, right? Yes, so this is what for 99. What about the other one? 90% means what is the time for 90%? 2.303 by K into log of 100 by 90% means what? Only 10 is left. What is log 10? 1. So this is 2.303k is there, 2.303k is there, here 3 time, here 1 time. So overall what you can say, time required for 99.9% is equal to 3 time of this one, right? 3 into time required for 90%. So how much time is required? That 3 time it's required. One more question is there for the same pattern. The time required for 99% completion, how it is related to 90%. We can say like this, for, let me write a 99% and how to write a 90%. 99% we can write that 2.303 by k into log of, what is initial 100. 99 gone, what is left? 1. What is log 100? Log 100 is what? Log 10 square. Log 10 square is 2. But here already we said that the same one we calculated before, time for 90% is equal to what? 2.303 by k into, we got 1, right? The previous one. So here it is 2.303k into 2.303 by k 1. So this is 2 time, right? So we can say time for 90%. So this is what? 99, right? Time for 99% is what? Double of time for 90% completion. So let's go with 2 time the rate is increased. Clear? Next one, A in Arrhenius equation. What is Arrhenius equation? K is equal to A into e raised to minus EA by RT. What is A is called? A is called Arrhenius factor, frequency factor, pre-exponential factor. All of these are A. What is A is called? Arrhenius factor, frequency factor or pre-exponential factor. All are related. And here is our last question. Probability factor P to account for that. According to the collision theory, rate equal to what? Rate is equal to P into ZAB into e raised to minus EA by RT, where P is called probability factor or steric factor. Okay, so probability factor is the measure of what? It is a measure of effective collision. It is a measure of effective. Probability factor higher means there is more effective collision chance is there, more rate can be produced. So dear, these are the 100 MCQ from the chapter Chemical Kinetics. Thank you all.